Okay, Module 2.3, Properties of Logarithms. There are 4 properties of logarithms that you're going to need to know very well in order to manipulate logarithmic equations and solve them. It's just something you kind of have to commit to memory, and there's only 4, and they're fairly straightforward, so you should be okay. Logarithmic statements can be expanded, what we call expanded and condensed. You might even see the word simplified, depending on the function involved. Okay? So, first one is the product property. If you see a logarithm, log b mn, meaning that this answer here can be split down into 2 factors, then, or even more than 2 factors, then if you take the log of the first and add it to the log of the second, you will come up with the log of the product. So log b mn equals the log of bm plus the log of bn. So for example, if you have log of 3 9x, when you're calculating that, that would be the same as log of 3 9 plus the log of 3x. You just simply break that apart, write it as an addition problem if you have multiplication going on here. Okay? So if you have multiplication going on, then you're dealing with adding. Okay? Next one would be the quotient property. If you have an answer in this area of your log that can be turned into a division problem, log b of m over n, then the equivalent is log of bm minus the log of bn. So if you're dealing with division, then when you expand it, this is called expansion, okay, on this side. This would be the expansion. Okay. Then you're dealing with subtraction. So for example, log of 1/4 to the 4/5 equals the log of 1/4 4 minus the log of 1/4 5. Okay. Sometimes you're just going to simplify them, and you're not going to go any farther than this yet. We will get to a point where you can calculate this, but we're not there yet. Okay. The power product says that if you have a log bm to the p power, that can be expanded to where you bring the p out to the front, and that now becomes a multiplier of your logarithm, which kind of makes sense because when we have a number multiplied by itself over and over and over, it's how many times you're multiplying that number. So, and remember that logarithms are giving us an exponent value, aren't they? So that's how many times that exponent is being used. So for example, log 2 of 8 to the x, that x would travel out to the front and it would become x times the log of 2 to 8. So if you see a power, you see an exponent, that means to multiply. Okay? The last one you need to know is equality. If log of bm equals the log of bn, then m and n have to be equal. So let's think about that for a minute. If I have log of 6 to the 36 equals log of 6 to some number, and they have to be equal, then I know that that number has no choice but to be 36. It has to be 36 because they have to be equal. Okay? So if this is my m and this is my n, then those two must be equal. That's what that statement is saying. It's really nice for you to be able to solve equations like that because, for example, if we have log 8 parentheses 3x minus 4 equals log 8 parentheses 5x plus 2, then I know that this value and this value must be equal to one another. I can pull them out with any logs, I don't even care what the logs are at this point, and set them equal to each other and solve for x. So this enables you to solve for x. Okay? So now we're going to do some practice on the product property. So log 4x, how would you expand that and write that out? Well, I have got a product going on, so I know that for my product property, I know that it's going to be addition. Okay? So I'm going to have log 4, 7 plus the log of 4x. If I've got multiplication here, I know I have to have addition here. Log of 2, 32xy. Well, now I've got a couple things going on. I have 32 times x times y. You can make this pretty small. Okay? But I actually know a value for log 232, but just for ease of rewriting this. I'm going to leave it alone for now. So that's log of 232 plus the log of 2x plus the log of 2y. Now ask yourself, if I wanted to, could I find a value for log 232? It's something we did in class today, actually. So 2 to what power, and that's what it's asking you. 2 to what power gives me 32? So that actually has a value of 5, which will come in handy here fairly quickly when we're trying to solve logarithmic equations. Okay. In number 3 and 4, what do you notice that you already have? Well, you've already got an addition sign, which means these are already expanded. I need to condense them. Okay. So these are expansion. You'll also see the word simplify. These you need to condense, okay, or simplify. So what I need to look at is what my values are there, and I know since it's addition, then I'm going to multiply them back together. So if I put them back together, I just get log 7, 6a. Number 4, I get log, remind me again, if I don't, talk to your computer right now. If I don't have any base there, what number is that? That's right, it's a 10. Good. So if I have addition here, I'm going to have 3 things that I'm multiplying together. So it'll be log 10 RST. You can just write it as log RST. That's fine. Because we understand that to be a 10 even if we don't see one there. Oh, sorry, this should have been log 2, 3 is about 1.5850. Can you write that into exponential form for me right now? So do you fully understand what that means? I'll give you a second to do that. So what that means is 2 to the 1.5850 equals about 3. It means close to 3, but not quite 3. Not exactly 3. Okay? So let's see what we can break 48 down into. So log of 2, if they're giving us a 3, let's use that. So I know that 48 can be 4 times 12. I know that I also know that that 3 and 16 multiplied to 48, we can do it either way. Okay? So what can you break 12 down into? Well, I've got the log of 2, 4 times 4 times 3, right? And each one of these has a value. What's the log of 2, 4? 2 to the what power gives me 4? 2. So if I'm going to expand this, it's going to be the log of 2, 4 plus the log of 2, 4 plus the log of 2, 3. Now I have values for each of those. I know that this equals 2. 2 to the second power equals 4. I have another one of those. And then log 2, 3 is about 1.5850. So total I should get 5.5850. Let's see if we get the same answer down here. So expanded, that means log of 2, 3 plus the log of 2, 16. Okay, so that's 1.58, because they told me that, 1.5850 plus 2 to what power gives you 16? Well, I know 2 to the third is 8, so 2 to the fourth must be 16. And if I total this up, I again get 5.5850. What I want you to do when you get these answers, because you're probably saying to yourself, okay, that's a nice answer, I have no idea what that means. But you do know what that means. That means 2 raised to the 5.5850 should give us about 48. That's what that means. So check that on your calculator. 2 to the 5.5850 should give me 48.001248. Okay, so fairly close to 48. If you rounded that off, it would be 48. It's a good way to check your answers and make sure that they're reasonable answers when you're doing logarithms. I do it constantly, just to kind of double check myself. Okay? All right. So let's practice some quotient property practice. You're going to do the same thing. You're going to expand or condense the following log depending on which function you're doing. The first two are going to be expanding. Second two will be condensing. Okay? So I definitely have as soon as I see a fraction, I know that I've got a quotient going on. And when I have a quotient, I know that I need to do subtraction. Okay? So this would give me the log of 4, 7 minus the log of 4, 3. The question you might have is, since I'm doing this, does it matter which order I am subtracting in? It absolutely matters what order you're subtracting in. Okay? The numerator always goes first, subtract the log 4 of the denominator. Okay? Number 2, you should get log 11 of x minus log 11 of 4. Now let's go back. Now that we have to condense, right? You're going to have log 7, we know that. Ask yourself, what am I starting with? That's going to be my numerator. What am I ending with? That's going to be my denominator. So log 7 of 4d. As soon as you see subtraction, division should be going into your head because those are the functions that are related to one another. So I should have log, and our numerator is going to be r, and our denominator is going to be 3. Okay, on number 5, you need to correct your work. This should actually be log 3, 15. Okay. So, how can I write that as a quotient with maybe numbers over here that might help me? So log of 315 could be written as 15 divided by 3, couldn't it? Log I'm sorry. Actually, number 5, you're going to skip altogether, and we're going to give you a replacement. You're going to have plenty of practice on this in class, so we will get to that during class. Okay, so the power property practice, you're going to do the same thing, expand or condense, depending on what you see. If you see that you've got the power attached there, then what you're going to do is you know that you have to expand it. Okay? If you see that it's got a number out in front, that tells you that you need to condense it because it's already been expanded. Okay? So let's do this. So power property tells us that that exponent comes out to the front and becomes a multiplier. So this would be x log 4, 7. Okay? If I could write this all as one exponent, let's see. So I would have, let's do this as a quotient first of all. We've got a quotient going on, so we've kind of got 2 steps on this one. So we would have log 2 of a squared minus log 2 of bc to the 4th. But now there's no parentheses around that, so that c to the 4th only applies to that c. In order for us to move that out to the front, we would need that to be in parentheses, and it's not. This one's actually going to stay just like it is. However, this 2 applies to that a, so it's going to come out to the front. So you get 2 log 2a minus the log of 2bc to the 4th. Please understand, had there been parentheses around the bc, then that 4 would apply to both of them, and it could be moved out to the front of the log. But because it only is on the c, there's no power that we can take from both of them. So this is going to stay just like that. Okay, if we need to condense them down, so I've got an addition here that tells me some kind of multiplying is going to go on, and I've got a coefficient out in the front that tells me that I'm going to have some kind of power going on. You're often going to see log functions that you have more than one property in action at the same time. So let's move the exponent back first. So we would have log 4, 3 plus log 4, and that's going to be a to the 8th. Now, because you have addition, you know that those two numbers need to be multiplied back together. So you would have log 4, 3a to the 8th. Okay. Here we've kind of got both going on. We've got a subtraction and an addition. So what on earth are we going to do with that? Well, let's kind of clean up these a little bit first because I've got coefficients out in the front, which tells me I'm dealing with power property. So let's sort each one of these. And each log is its own department. So this would change to log x4, x to the 4th, minus log y to the 5th, plus log z to the 3rd. Okay, now what have we got going on? Now I've got this is my divisor minus these two are being multiplied together. So you would have y to the 5th and z to the 3rd. These you always need to deal left to right, deal with first things first, then the next, okay? All right, so now we're going to try and solve some logarithmic equations now that we have some information on how to simplify these. So as soon as I see and subtract, only deal with this side of the equation for right now. So I know I've got what kind of thing going on. What property am I using? Product, quotient, power, or equality property. Okay, subtraction tells us that we have quotient property going on. So I'm going to rewrite this side of the equation, log 4. I know I've got to have a division thing going on, x and x minus 6 equals 2. Now here's where you have to go back to your basic, how do I convert things from a log back to an exponential equation, okay? Because that's going to give us a really easy way to solve this. So here's where you want to change back to exponential form, okay? So how do we do that? Our base is 4. We're raising it to the 2nd power, and that gives us x over x minus 6. So I have 16 equals x over x minus 6. I'm going to multiply both sides by x minus 6 so I can get rid of that out of my denominator. So I would have x minus 6 times 16 equals x. I need to go ahead and do distributive property, so I would have 16x minus 96 equals x. Move my 16x to the other side. So I would have negative 96 equals negative 15x. Then I just need to divide out. Whatever that reduces to, let's see, go negative divided by negative, it's positive. 3 goes into 15 5 times. 3 goes into 96 32 times. Okay. Remember, in this case, this isn't a power. We didn't just find an exponent here. We just found a value for x, because now we've got equations we need to solve that involve logarithms, but that doesn't mean you're always solving for the exponent. Okay? Because this told us 4 to the power of 2 gave us this equation of unknowns, which is what we just figured out. Okay. Last one, aren't you happy? So 3 log 5x minus log 5/4 equals log 5/16. The nice thing is we've got 3 of the same base going on. That's going to help us in a minute. So let's rewrite this first one. Since I have a 3 out in the front, I know that that's log 5x to the 3rd minus log 5/4 equals log 5/16. Okay. So now, because that's subtraction, I know I'm going to use the quotient property. So I would have log 5 x cubed over 4 equals 16. Oh, sorry, excuse me, equals log, that makes a big difference, 5/16. Now I've got that equality property going on. I have the same base, those are fine. If they are equal, if the logs are equal, then I know that these two amounts have to be equal. So x to the 3rd divided by 4 has to equal 16. So I've gotten rid of the logs altogether. Now I can just solve for x. So I multiply both sides by 4. I would get x cubed equals 64. In order to solve that, I would take the cube root of both and the cube root of 64 is 4. Okay? I know it's a lot. We'll do practice. But you should definitely be doing homework on these because they do require practice for you to get good at them. Okay, something that we've kind of talked about in class that I think needs a bit of a review is using fractional exponents, or what are also called rational exponents. Of course, a fraction makes up a ratio, so they're called rational or fractional exponents. So logarithms show us that all exponents are definitely not whole numbers. Any power can be written as a fraction, which will be called a fractional exponent. I tend to call them fractional exponents. You will also hear rational exponents. They mean the same thing. Just means that your power is not a whole number, okay? The general form for that is base. You have your base, and you're raising it to the power divided by the root, where the numerator of the fraction is the power, and the denominator is the root. For example, 2 to the third can be written as 2 to the 3 over 1. We, of course, don't usually put whole numbers over 1, but you definitely can, which is the same as the first root of 2 to the third. Okay? Don't often deal with first roots. If you're going to write that, that is exactly how it would be written. Okay? 8 to the 1/3 means the third root, this is our root, this is our power. Power goes within the radical, root goes to the outside of the radical. So that's something you probably should write down. Okay? Power goes in here, root comes out here. Usually when we're doing square roots, you don't ever have the 2 written in there, it's just understood that it's a 2. Where you are finding the third root of 8. So you need to ask yourself, what number multiplied by itself 3 times gives me 8? You're looking for a triplet. If you're looking for square roots, you're looking for pairs. Okay? The square root of 4 equals 2. 2 times 2 equals 4. You're looking for a pair of 2s. If you're looking for third roots, you're looking for triples. So we can break 8 down into 2 times 2 times 2. You have a triple of 2. That is your third root of 8. Okay? In evaluating fractional exponents, it's really a lot simpler to take the root of that number first and then raise it to the power. It's kind of like when you're dealing with fractions, when you're multiplying, that if you cancel first and then multiplying, it's much easier. You have a smaller number usually to deal with. You can certainly take the root of any number, but it's kind of complicated, so let's keep it simple. Okay, so I want you to practice writing 1 through 4 as a radical and 5 through 8 as exponents, and then come back and check your work. So number 1, 9 to the 1/2, that would be the square root of 9. 7, you could put a 1 in here if that helps you while you're learning how to do these. 7 to the 1/3 would be the third root of 7, or 7 to the first. X to the 7 over 8, let's make that a little bigger for you, would be the 8th root of x to the 7th. A to the 5/6 would be the 6th root of a to the 5th. Okay? All right, number 5. Write as an exponent. Like I said, anytime there's no number written out here, it's assumed that it's a 2. If you need to write that in, great. You probably don't, but that's up to you. Okay, so if I write this as an exponent, 7 to the 1/2, my power is 1, my root is 2. Number 6, my power is also 1, so 18 to the 1st, my root is 5. Number 7 is 8 to the 1/4. The interesting thing is, think about if you can write 8 as another number, which should also be 2 to the 3rd. So if I asked you to write it as a base of 2, this is going to come in handy when we're doing same base and we're changing things to same base. That is going to be 2 to the 3/4 power. Those are equivalent. Those mean exactly the same thing. 2/3 and 8 are equivalent. 3 is my power, 4 is my root. In this case, 1 was my power, 4 is my root. These are equivalent. Okay? And then number 8 would be y to the 3/4. Okay? So now you're going to use what you know about fractional exponents to solve some of the logarithms. Okay? The easiest thing to do is change to exponent form. If you can with logarithms, you're going to do that because it's definitely going to make life easier for you. So that would be our base is 8. I'm raising it to the 4/3 power, and that's going to give me x. Remember back in the section ago where we did raising a power to a power? Okay? This is where I'm saying it's easier to take the third root of something and then raise it to a power. So that's like you're writing to the 1/3 and then raising it to a power. 1/3 times 4 is 4/3. I've got the same amount here and here. This means the third root of 8 all raised to the 4th power. So the third root of 8 is 2. I'm going to raise that to the 4th power. I would get 16. You're thinking, Miss V, that sounds weird. I don't know if I could do that. Check it on your calculator. 8, y to the x, put in parentheses 4 divided by 3. Oh, and look what you get. You get 16. Okay? All right, last one. Log 16x equals 5/2. Rewrite as an exponent, so it'll be a base of 16 raised to the 5/2 equals x. This is the same as 16 to the 1/2 times 5. 5 times 1/2 is 5/2. This means the square root of 16 to the 5th. So the square root of 16 is 4. I'm going to raise that to the 5th, and I get 1,024. Let's try that and see if my answer is right. So I'm going to do 16 y to the x, 5 divided by 2, and I get 1,024. You can definitely check your work backwards and forwards with logarithms. Okay, you surely need to know how to operate your own calculator. They're all different, so mine's not going to be the same as yours. You need to know how to do that on your own. Okay, and I think that is the end of Module 2.3. Thank you.